logic gate symbols, ito yun, pag magagawa tayo ng mga circuits. So we use this logic gate symbol. So for number 1, we have an OR gate. For number 2, we have NOR gate. For number 3, AND gate. Then for number 4, NAND gate. And then for number 5, XOR or exclusive OR. Then for number 6, we have XNOR. And then for 7, buffer. Then for 8, you have the NOT gate or inverter. Okay, for next lesson, for this week, since week 5 na tayo, so ayan, we were going to tackle more on about logic gates. Uh, I will re-share my screen. Ayan, can you confirm kung meron na kayo nakikita sa
Yes
screen?
po, sir.
Okay, so
Po, sir.
introduction to logic gates. And then pa-confirm din kung nagta-transition yung slide.
Yes.
Okay, so for this chapter or module, so we're going to identify the basic gates and describe the behavior of each, and then describe how gates are implemented using transistors, combine basic gates into circuits, and describe the behavior of a gate or circuit using Boolean expression, truth tables, and logic diagrams. And so, ang pinaka-importante dito sa chapter na to, yun, na kailangan natin ma-identify magiging Boolean expression, truth tables, and logic diagrams. And first, we define the terminologies used in this chapter. So first, we have a gate. So yung gate, a device that performs a basic operation on electrical signals. And then next, we have circuits. So gates combine to perform more complicated tasks. And then how do we describe the behavior of gates and circuits? So we describe it by using, first, we have Boolean expressions. So ito yung last time yung ni-lecture ko. So by using Boolean algebra, a mathematical notation for expressing two-valued logic. And then we have logical diagrams. So logical diagrams naman yung graphical representation of a circuit that each gate has its own symbol. So ito yung kaninang define natin yung mga logic gates, yung mga symbol, yung logic diagrams. Then next, we have truth tables, a table showing all possible input value and associated output values. And so lastly, we have these truth tables na yung laman ng truth tables natin, yun yung input and output. And so first, we have this NOT gate. So ang definition ng NOT gate, a NOT gate accepts one input signal, 0 or 1, and returns the opposite signal as output. So dito sa illustration, makikita nyo ito yung Boolean expression. We have x equals not a or x equals a complement. So dito, you could use also this symbol. So for example, ayan, yung other Boolean expression ng not is x equals ayan, not a. Ayan, so pwede siyang ganito or pwede siyang underline, yung underline sa ibabaw. So x equals not a, yung ibig sabihin ng Boolean expression na yan, or x equals a complement. So, yung logic diagram naman niya, since 'di ba ito not gate, so ayan. And then ito yung A, siya yung input, and then yung X yung output. And so meaning X equals A complement. So pag ilalagay natin siya sa truth table, ayan. So yung A, so sa A, we have two inputs, the 0 and 1. And then kapag i-output na natin siya, since 'di ba yung sabi, yung palagi siyang opposite nung yung output palagi siyang opposite nung input. Kaya pag ang input niya 0, so since not 0, kaya ang output niya 1. And then pag ang input niya ay 1, so not 1, 0 yung output. Ayan, so ayun yung various representations ng NOT gate. So next, we have this AND gate. So an AND gate accepts two input signals. So if both are 1, the output is 1. So otherwise the output is 0. Okay, sige. Yung sa AND gate, ano nga ulit arithmetic operation yung ginagamit natin for AND gate? Anyone? Anong arithmetic operation for AND gate?
Sir, pakiulit po.
Dito sa AND gate, ano yung ginagamit natin arithmetic operation?
Sir, yung X equal po A times B. Yan.
Ano nga siya? Anong arithmetic operation? Di ba we have four arithmetic operations? So we have addition, subtraction,
Plus, sir.
multiplication, division. So pag AND gate, ano yung ginagamit natin?
Plus po.
Wrong. Wrong. Hindi plus. Anyone?
Multiple po, sir.
Okay, multiplication. So for AND gate, 'di ba, we use multiplication kasi tina-times natin, ino-multiply natin yung two inputs kapag AND gate. So 'di ba dito sa Boolean expression na 'to, ang ginagamit natin multiplication. So x equals a times b. And then for logical diagram symbol niya, so ayan, we have two inputs, we have a and b, and then x yung output. So kapag nilagay natin na sa truth table, ayan, so mapapansin nyo sa truth table, yung sabi, if both are 1, the output is 1. So makikita nyo kapag both input ay 1 for A and B, so A is 1, B is 1, so the answer is 1. And doon lang siya magto-true or doon lang siya magwa-1 pag if both input are 1. Kasi we use 'di ba the multiplication. So pag kinumpit mo din 'yan ng 0 times 0, and so as long as may 0 siya, 0 siya. And then kapag both input niya ay 1 kasi 1 times 1, so doon lang siya magkakaroon ng output na 1. And kapag AND gate. And then next, we have OR gate. So an OR gate accepts two input signals. So dito naman sa OR gate, if both are 0, the output is 0. Otherwise, the output is 1. So for OR gate, ano naman yung arithmetic operation na ginagamit natin?
Addition po, sir.
Okay, so correct. For OR gate naman, we use addition. Kung saan pinagpa-plus natin yung mga inputs. So dito, yung Boolean expression niya, makikita nyo we have x equals a plus b. So, pag dinrawing natin yung logic diagram symbol niya, so first, i-drawing natin yung OR gate, ito. And then we have input, yung A and B. And then yung output is X. So since OR gate, yan, ipagpa-plus lang natin yung dalawang input. Tapos sabi, pag OR gate, if both are zero, doon lang siya nagkakaroon ng output na zero. Pag parehas zero yung dalawang input. So for this example, we have A and B about zero, kaya zero. And then, pag kinompute naman natin siya, kasi since addition, ganun pa din yung lalabas. Since 0 plus 0, 0. 0 plus 1, 1. 1 plus 0, 1. And then 1 plus 1, 1. So, ayan. So, ayan yung various representation ng OR gate. So, next naman, we have XOR. So, an XOR gate accepts two input signals. If both are the same, the output is 0. Otherwise, the output is 1. So, dito naman sa XOR gate, since ano pa din siya, or pa din naman siya, nilagyan lang ng line para maging exclusive OR. So, addition pa din yung ginagamit. And then, gumagamit lang ng ganitong symbol, yung plus na may circle. So, x equals a plus b. And then, pag dinrawing niyo yung logical diagram symbol niya, meron lang siyang line before no OR gate para maging XOR gate siya. So, dito, we have two inputs ulit, yung A and B. And then, we have the output X. So, mapapansin nyo, pag exclusive or XOR gate siya, yung output niya 0 kapag parehas yung dalawang input na value. For example, yung A and B parehas silang 0, kaya 0. And then, parehas 1. Same yung value ng input na A and B. Parehas silang 1, parehas silang 0, kaya ang output 0. And then, kapag magkaiba, pag two different inputs, kapag A yung 0, B is 1, and then ganun din yung opposite. If A is 1, B is 0, doon lang siya nagkakaroon ng 1 output. And so, pag XOR, ang palatandaan kapag XOR siya, kapag two both input are the same 0, then same 1, doon lang siya nagkakaroon ng 0 output. And then kapag different, doon lang siya nagkakaroon ng 1 as an output. And then also, note the difference between the XOR gate and the OR gate. They differ only in one input situation. When both input signals are 1, the OR gate produces a 1 and the XOR produces a 0. So, XOR is called exclusive OR. Ayan. So, yung acronym na exclusive OR and si XOR. So, next, we have this NOT AND or NAND gate. So, ganun din. The NAND gate accepts two input signals. So, we have this Boolean expression na x equals a times b or x equals ayan yung a na may underline, a. Ayan, either a times b complement na ganito or x equals a times b. Ayan, x equals not a times not b. And then, same, we have this logical diagram symbol. So, x is the output and we have two inputs, a and b. And then, meron lang tayong circle dito to denote na may not siya, kaya not non-gate. Tapos, yung truth table niya, ganito. So, sabi, if both are 1, the output is 0. And then the otherwise is 1. So, dito, opposite naman to nung NAND gate, si NAND gate. So, sabi, if both are 1, and the answer is, the output is 0. Kasi, 'di ba, binaliktad lang yung sagot nung sa NAND gate. So, kapag kukumputin natin, we have 0 times 0, 0, 0 times 1, 0, 1 times 0, 0. Then 1 times 1. Tapos may not siya. Kaya not 0 is equals 1, not 0 equals 1. And then not 1, we have 0 as the output for NAND gate. And kaya naging 0 yung 1 times 1 dito for NAND gate. And then next, we have the NOR gate that accepts two input signals. If both are 0, the output is 1. Otherwise, the output is 0. So, opposite naman ni NOR gate yung OR gate. And then first, we define the Boolean expression. So, we have x equals a plus b complement, or x equals ayan, x equals not a and so x equals not a plus not b. And then same, we have this logical diagram symbol with x yung output. Then we have two inputs, A and B. And then we have this NOT to make it NOR gate. And then pag yan, lagay natin siya sa truth table. So sabi, both are 0 and the output is 1. Then otherwise, output is 0. So dito, opposite lang siya ng OR gate since 0 plus 0, di ba? 0, then 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 1. And then, i-invert lang natin kasi meron siyang ganito since NOR gate. So, not 0, ayan, kaya 1 yung 0 plus 0. And then, yan, yung mga not 1, ayan, kaya 0 yung answer. So, this is the various representation of a NOR gate. So, to review, ayan, a NOT gate always inverts its single output. And then, an AND gate produces 1 if both input values are 1. And then, an OR gate produces 0 if both input values are 0. And then, for an XOR or exclusive OR gate produces 0 if input values are the same. And then for NAND or NOT AND gate produces 0 if both inputs are 1. And then for an OR gate produces a 1 if both inputs are 0. So next, in constructing gates, first we have transistor. So transistor, a device that acts either as a wire that conducts electricity or as a resistor that blocks the flow of electricity. And then depending on the voltage level of an input signal, so a transistor has no moving parts yet acts like a switch. And then it is made of semiconductor material which is neither a particularly good conductor of electricity nor a particularly good insulator. So yun yung meaning ng transistor. So syempre, if we're going to construct a gates or circuit, ayun yung kailangan natin. We need a transistor. And then, ito yung sample ng combinational circuits. Ayan, so kapag combine natin yung different logic gates, so we could have gates are combined into circuits by using the output of one gate as the input for another. Ayan, so dito makikita natin may tatlo tayong logic gates. So we have this OR gate. So we have this OR gate na merong input na DNE. And then meron pa siyang dalawang AND gate. So dito we have this AND gate of A times B. And also another AND gate na kung saan tinatimes sa C. And then we have this output X. Ayan, so ito naman yung truth table ng combinational circuits. So as you can see, ayan, we have 3 inputs require 8 rows to describe all possible inputs combinations. Ayan, so kaya siya 8 rows, 'di ba? Kasi 'di ba 2 cube. So in 2 cube we have 8. Since 'di ba tatlo yung inputs niya, kaya 2 cube then equals to 8 yung possible input combinations. Yan. So we have 1, 2, 3, 4, 5, 6, 7, 8. So among the given inputs, dun sa kaninang diagram, ayan, ang possible combination kung ilalagay natin sa truth table. So we have these 8 rows. So this same circuit is using the Boolean expression of AB plus AC. So next, we have this other combinational circuits. Consider the following Boolean expression. So we have A times B plus C. So 'di ba, we have this AND gate na meron siyang input ng A. Ayan, kaya we have this A. So 'di ba commonly we use para mag-multiply, we also use parentheses. Kaya we have this A times and A times. Tapos, yung nakadugtong sa kanya, OR gate. Na OR gate na meron dalawang input. So, si B and C. So, since OR gate yan, gagamit tayo ng addition, kaya B plus C. And kaya yung laman nung parenthesis, ayan, B plus C. Kaya yun yung Boolean expression niya. So, A times B plus C. So, ganun din. Kapag ipa-plot natin siya sa truth table, so we have this truth table ng A, B, and C as the input. And then we have this A times B plus C as ito yun yung as the pinaka-output. Ayan, to write the truth table, syempre magsisimula muna tayo dun sa pinaka lowest to highest. Kaya makikita nyo meron siyang 0, 0, 0, 0, 0, 1, 0, 1, 0. Then ang highest niya is ayan, si 1, 1, 1. And then dito, kinompute niya lang yung B plus C ito. And so kung kukumputin nyo yan, and di ba, 0 plus 0 plus 0, we have 0. So 0 plus 0 plus 1, we have 1. And so forth. And then kapag na-compute na yung B plus C, ay meron pa tayo dito yung pinaka-output na. Kung saan si B plus C, ita-times na natin siya dun sa isa pang input which is A. Kaya A times B plus C. And so makikita nyo kung ayan, kung ito, ita-times pa natin sa A. So 0 si A, 0 si A, di ba? since may zero dito and multiplication, kaya yan, nagiging zero siya. Kaya, di ba sa multiplication sa end gate, as long as may zero, zero, since merong zero, yun yung A, ayan, kaya zero yun dito. And then dito sa next, sa 1 times zero, kaya zero pa din yung answer. And then dito we have na 1, kasi 1 times 1, we have 1. And then for the next, we have this another 1 times 1. Kasi 'di ba B plus C is 1 and then A dito is 1. So 1 pa din. And then same din lang din dito sa last na 1 1 1. Since B plus C equals 1 then times 1 and we have this 1. And so ayan lang yung about sa logic gates. So, ang importante dito, ayan, ma-define natin yung given. And kapag given yung Boolean expression, ma-derive natin yung equivalent logic gates niya. And also yung truth table, kung saan merong input and then yung output. Okay, for the next activity natin, dun sa next module, okay, I'll reshare my screen. Pa-confirm kung meron na kayo ulit nakikita sa screen.
Yes po, sir.
Okay, sige. For our next activity during laboratory, ayan yung time natin sa laboratory. So, I want you to download this Android app. Ayan. So, meron siyang 30 stages. Yung title ng app or yung Android game, ayan, called Logic Gates. So, ayan yung pangalan ng app. Logic Gates Electronic Simulator and Learning. Ayan, by using this app, ayan, you can simulate, play, and learn logic gates. And so marami siyang examples na pwede nyo paglaruan. And then, yan, yung games contain of lots of levels, starts with easy gates, and then it should allow player to learn by playing. And you can download it in Google Play Store, and then you can also find it yung sa application inside your yung OTG flash drive ay nandun din daw siya. So you could install or download it on your Android phone or smartphones. And then yung score nyo, i-record natin siya as equivalent to your laboratory grades. Yung magiging highest score nyo dun sa app, ayun yung i-record natin. Ayun. And then for next meeting, and yung continuation nung ano, nung logic gates natin, and kung saan magpa-plot na tayo ng sarili natin logic gates based sa given truth table or Boolean expression. And then for next week, we're going to tackle this K-map. K-map or Carnot map, or what you call K-mapping in logic gates. And so for next week, week 6 na tayo. So 3 weeks na lang, we will have na din yung your midterm. Bali, ito na din pala yung next week yung last lesson nung sa logic gates, kasi ang susunod na for week 7 and week 8 yung introduction na sa Androino. And so kailangan mas ma-familiarize pa tayo dito sa mga logic gates. Ayan, kaya yun, pag download niyo yung app na yan, ayan, try to play with it. Ayan, para mas maging ma-familiarize kayo dun sa mga different sample ng mga circuits or logic gates. Para madali na lang kapag nag-Androino na tayo. And then, as a reminder, yung sa mga hindi pa nagta-turn in nung mga last laboratory activity nila. Ayan, so for week 4, meron pa dito eh. Ayan, so meron pang 12. Ayan, so meron pang 12 na hindi nagta-turn in or submit. So si Jose Adrian, Rica Angelo, Christian Benedict, ayan guys, Sir Byron, Michael John, si Eldon, Arvelin, Carlin May, Michael Joseph Mendoza, John Rafael Morales, Sophie May, and then Charlotte Tolerad.
Sir, yung gusto ko nyo lang time at yung sa open po, nakaayos ko po.
Okay, basta i-try nyo mag-submit bago mag-midterm. Pero
Ay po,
syempre
sir,
may
thank you.
pero syempre may minus na para fair naman dun sa nagsasubmit on time. May minus yung mga nagsasubmit ng date. And then for the last week activity and for the worksheet 5.1, so marami pa yung hindi na to turn in or submit. So halos kalahati pa lang yung meron. So ito, makikita nyo naman sa screen kung nakapag-submit na kayo or hindi pa. So yung mga missing, so meaning ito yung hindi pa. And so we have Angel, Vinelli, Art John, ayan, Rick Angelo, Christian Benedict, Daniel Behil, Shamgar Ezekiel, Echo, Geister Byron, si Eldon Hakosalem, Carlin May, Michael Joseph, John Rafael, Renz Alan, Sofia May Nervis. Then we have Berisane Oliveros, Pinky Piquite, Crystal Reina, and then Charlotte Toleran. Okay, sige. I-check din natin yung sa week 3. So, sa week 3, meron pa ding natira, yung 17. And so, meron pang hindi pa nagsasabit dun sa number system conversion natin. And so, ayan, naka-display naman yung mga names nyo to confirm. Ayan. So, anything else? May question pa ba?
No po, sir.
Ano yan?
No po.
Sige, Nico, ano yung, meron pa bang question? Okay, sige. For the laboratory activity, I will create a Google Drive and then paki-screenshot yung yung score nyo dun sa app and then I will record it as your laboratory activity grade. I-share ko na lang mamaya sa JC yung link kung saan nyo i-upload yung yung screenshot. So, 'di ba once na na-upload nyo yung app, yung kanina, yung shinare ko na Logic Gates app, ayun, try nyo siyang laruin and then yung pinaka-high score nyo, yun yung screenshot nyo and then i-save nyo dun sa Google Drive folder na ibibigay ko mamaya sa JC. Ayun. Yung deadline naman niya until next meeting. Next meeting natin is on March 22. And so you could upload your final score, yung screenshot ng final score nyo dun sa app until March 22 Monday. Ayun. So nakakuha ba? Wala na kayong questions?
Wala po.
Wala na po, sir.
Okay, sige. So wala na. I will just screenshot lang yung attendance. Okay, sige. Okay na. So, let's call it a day. Thank you, everyone.
Thank you po,
Thank you po,
sir.
sir. Thank you so much.